Okay, this is Algebra 1, Lesson 36. We're going to talk about fractions. If we multiply fractions, 2 over 3 times 5 over 7, we simply multiply the numerator times the numerator and the denominator times the denominator. And then we simplify if we can. Now, since a variable stands for an unspecified real number, all the rules for real numbers also apply for variables. So, for instance, if I had mx over 4y times ax over 2y, the same rule applies. You do numerator times numerator. This becomes amx squared over 8y squared. All right. The distributive property of real numbers is also applicable to expressions that contain a fraction. So expressions that contain a fraction are often referred to as rational expressions. So let's look at this first, distributive property. We have x over y times a over y minus b. How many terms do we have inside this parenthesis? We have two. We have a fraction and a whole number. They happen to be letters and variables. That's the only difference. We still have to distribute this fraction to each term. So then this becomes ax over y minus bx over y, and we simply make that to y squared minus bx over y. Okay, so let's continue and do some more just using your distributive. Let's look at example 36.1. So we want to use the distributive property to expand this rational expression. So we have x squared over y squared times x squared over y minus 3y cubed over m. So again, you've got two terms, and this is going to be multiplied through both terms. So you've got x squared times x squared over y squared times y minus, remember this negative is married to this term right here, x squared 3y cubed over y squared m. And so we have to simplify. Don't we have, now we're using our exponent rules. We have the same base, so it becomes x to the fourth over y cubed, because we're in this implied 1, minus, we're going to put this with a coefficient first, and then in numerical order, x squared y cubed all over y squared m. And there's your answer. Let's look at another one. Let's look at example 36.3. So we're going to take a, b, all over c squared times, it's still a fraction. Just because you have letters, it's still a fraction. axb over c plus 2bx minus 4 over c squared. Again, we must distribute. We've got three terms within the parentheses, and we must distribute this fraction right here through every term. So we get ab times xab over c squared c plus, and this is like a whole number, we have to put over 1, so to multiply fractions, so we get ab 2bx over c squared, because c squared times 1, minus, this minus is married to that, minus ab 4 all over c squared c squared. So now we're going to simplify. Now we use our product rule for exponents or powers or bases. How do we multiply variables? Well, you have the same base. So here we've got a squared, b squared, x, because these two combine and these two combine, over, this is implied 1, and remember you add the exponents. Okay, then plus, because you have a plus, anything to combine here, I'm going to put my 2 first, my a, and I've got two b's, which is b squared x all over c squared, minus 4ab over c to the 4th power. And you can't reduce, that's it, and that's your answer. You leave it just like that. Now let's look at well, no, that's good. Now I didn't on the last one simplify, but if I had let's say a b here, I can simplify this further. This goes to b to the 0 and b to the 1, or simply this becomes a squared bx over c cubed. So you can simplify within each term if you're able to do that. Okay? I didn't do it on the last one. I forgot there was the very last term you could have on example 36.1. So now let's go further and move to 36.b, and we're talking about exponents. And we're talking about signs and exponents with negatives. A negative in front of a number means the opposite of a number, where the negative exponent means something totally different. So let's look at a few. Let's look at 4 squared. That means 4 times 4, which is 16. Let's look at 4 to the negative 2. Well, this means you take its reciprocal, which is 1 over 4, and square it, then it becomes 1 over 16. Let's look at negative 4 squared. Remember, we said if the negative is not protected by parentheses, it doesn't get raised to the power. So this is like saying negative 1 times 4 raised to the second power, which is equal to negative 1 times 4 times 4, which gives me a negative 16. Okay, so look, let's move on. Let's do another one. And that's how you have to think of. Remember what the rules are. So, what if I did negative 4 squared? That simply means because it's protected by parentheses, everything inside of that is square. So now I have negative 4 times negative 4, which is simply a negative times a negative is a positive, so I get 16. Now let's look at negative 4 raised to the negative 2 power. Well, this is like saying negative 1 times 4 raised to the negative 2 power. I need to get rid of that negative exponent, so I need to take its reciprocal. So this is going to equal to negative 1 over, this doesn't change. It has nothing to do with that negative. That only applies to this 4. So the 4 goes to the denominator and it's squared. So now you have negative 1 over 4 times 4, which is negative 1 over 16. Okay? Please, please do not confuse this negative with that negative. Okay? So let's look at another one. Negative 4 raised to the negative 2 power. Well, now it's saying everything inside of this is raised to the square, so now we're going to do its reciprocal, 1 over negative 4 squared, which is 1 over negative 4 times negative 4, which is 1 over 16. It's as simple as that. So do your practice problems. There is no code for this homework. I will be checking your practice problems. Okay?